Hi everyone. I hope everyone's doing well and you're all learning exciting new stuff during your nano degree. I just want to quickly congratulate all of you that have managed to complete the second project by now. This is a huge achievement and you should be very proud of yourselves. The amount of work and determination needed was immense, as I'm sure you know, but you managed to complete it in time. Hopefully, it was not all frustration and hardship. Um, Hopefully, you learned a great deal of how JavaScript works and how we use it in various circumstances, mainly in the modification of the DOM. The next project is equally exciting in my opinion. We've all played those games back in the day, like Super Mario, all the others. Those pixelated games that have a character which is trying to avoid getting killed and is jumping around collecting coins, that type of stuff. Um, in this project, you'll be doing something similar. Hopefully, it will be a lot of fun, and as always, if you need anything, I'm here to help, so you're not alone in this. Um, just to mention that the deadline for this project is the 12th of May, so there's not much time. The time you had for the second project is bigger. So you have the experience now with projects and how they work. So hopefully you can plan ahead of time the time you're gonna need to complete the project. Okay, with that out of the way, let me welcome you to our seventh content webinar. What we're going to discuss today is tightly connected to what we talked about last week. Last week we tried to explain what the execution stack and the event loop are. We took a look at some of the more intricate characteristics of the JavaScript language, like single threading, runtimes, and others. Also, we explained what the web APIs are and why they're useful to us. Remember, in the browser runtime of JavaScript, we can use the web APIs to get additional threads to the single thread that JavaScript has in normal runtimes. So this week, we'll make use of our knowledge about the execution stack and expand on it by looking at what scope is and how we can use scope to create closures. These are a bit complex things, but they are essential for every JavaScript developer to know. So without further ado, let's start. I've made a presentation for you again, which I'm going to share after the webinar, because I think that it's better to actually see what I'm talking about instead of just looking at me the whole time. So let me screen share this presentation. Oops. Right, screen to share. And there it is. So here's our topic, scope and closures. And this is our agenda. It just has 6 points, but all of them are a bit complex and time consuming. So first off, we'll start with an explanation of what scoping in JavaScript is. Scoping is actually something specific to every programming language. It's not the same in JavaScript, in Ruby, in Python, so it's different everywhere. Since you're studying front-end development specifically, we'll take a look at what scoping is in JavaScript. So we'll disregard Ruby and all the others for now. After that, we'll move on to explaining the difference between the two types of scope, the global scope and the local scope. You've been making use of these two scopes all the time during their second project, so it's finally time to know what they actually are. Next up, we'll take a look at what lexical scoping means. It sounds pretty complicated, I know, lexical scoping, but it's just a name that sounds fancy. In fact, lexical scoping is pretty easy, but very important concepts in the JavaScript programming language. After that, after we take a look at lexical scoping, we'll explain what the roles of the execution stack and the scope chain are in scoping, and which of the two we should consider when we think about scoping. So a little bit of a spoiler here. One of them is not so much important when we consider scope, and the fact that the second one's called scope chain, you kind of get the drift of which one of the two is more important. So we'll take a look at that a bit later. And finally, after accumulating all the knowledge, hopefully, we'll take a look at what closures are and how we can construct them. Closures are considered to be an extremely difficult concept in JavaScript. That's only so because most people don't take the time to look at the JavaScript language in depth and understand the concepts behind scope. Um, that's really all there is to it. If you understand the concept of scope and scoping in JavaScript in general, closures are a very easy thing to use and construct. Um, in addition to that, job recruiters absolutely love to ask what a closure is in the job interview. So this is another benefit that you get from knowing what closures are, in fact. Okay, now let's start. Firstly, let's explain what scope or scoping in JavaScript means. Let's first take a look at a definition. So according to the definition, scoping is determining where variables, functions, and objects are accessible in your code during runtime. This means the scope of a variable, so where it can be accessed, is controlled by the location of the variable declaration. So here, runtime, as you may remember from last week, is the environment in which our JavaScript code is running. As we saw last week, JavaScript code behaves differently in the different runtimes. Here we see that scoping dictates where we can access a variable. So we see that the scope of a variable is controlled by the location of the variable declaration. So a variable declaration means where we have defined the variable. So where we have put the var or the let or the const declaration first. So that's where the variable declaration occurs. And that's in fact what's important when we consider what the scope of it is. So it's simply where it's defined, let's say. The previous definition might be a little bit too hard to grasp, so that's why I decided to kind of condense that definition to a much smaller and clearer one. This is actually what I came up here. Scoping in JavaScript answers the question, where can we access a certain variable in the code? So knowing that the concept of scope, we can determine where in our code we can access a certain variable. And as objects, arrays, functions, and pretty much everything, every data type can be stored in a variable, we can derive that pretty much everything is impacted by scope. So I hope that by now you're familiar with why scope is so important. Now, there are two types of scope in JavaScript. Um, those are local scope and global scope. So let's take a look at what each of them is and when they occur. So, and here, as we can see, the local scope consists of the variables declared inside a function. Also, we see that these variables can only be accessed inside of those functions. Um, so we can't access them from the outside. So imagine defining a function and declaring a variable in it. You can only access that variable inside the function. From the outside, it's invisible, unless, of course, you define a return statement inside the function, which gives the local scope access, uh, excuse me, the global scope access to the local scope. So um, here, actually, runtime again, we see uh, means the environment in which our code is running. As we saw last week, the runtime is very important to consider. So um, also we see that these variables can only be accessed inside of those functions. So like I explained, this means that they are essentially private. Um, they are something that belongs to the function and can't be accessed from outside. Knowing this, we can derive that we can have variables that have the same name uh, but stored in different functions. So we can have variables that have the same name, like cake, for instance, which are defined in two separate places and don't conflict each other. And that more or less is what the local scope is. It's the variables declared inside a function, which can only be accessed inside it and not from the outside. Now, let's have a few words about the global scope. Here we see that there is only one global scope, whereas we can have many local scopes. In fact, we have as much local scopes as we have functions inside our code. So the variables that are inside the global scope are defined outside of a function. Remember, the ones defined inside a function are in the local scope of that function, whereas if they are defined outside of the function, um, we have global scope. Also, these variables and the global scope in general can be accessed from any local scope, and as such, we can modify and alter variables in the global scope. So here we get a reminder of what scope is. Remember, it's the space or environment where we can access a specific variable, function, object, or whatever. Here's something interesting actually. Each new function defines a new scope. And since we know the two types of scope now, the scope created by each function is a local scope. In many other programming languages, however, in addition to functions, while blocks, for blocks, or if blocks, those if statements, those while statements, and others can also create a local scope. However, in JavaScript, that's not the case. Since we're studying JavaScript now, we don't need to pay much attention to the other programming languages right now. But it's useful to know that other programming languages have different features when it comes to scope. So what we should remember is that the only way to create a new scope in JavaScript is to write a new function. There is no other way to create a different scope than the global one besides writing a function. Okay, so knowing this, let's explain another very important feature of functions, and that's exactly lexical scoping. I know that lexical scoping sounds a bit crazy right now, but the idea behind it is pretty simple. Lexical just means where the function is written inside of our code. So, is it in the global scope? Is it inside the for loop as a callback? Is it inside another function? That's all got to do with the lexical place of the function. So lexical scoping means that if a function is written inside another function, the inner function gets access to the scope defined in the outer function, which is also called a parent function. So this is something I want to point out because later in the presentation we'll refer back to this definition. I know that right now you must be a bit puzzled by this, so let's look at an example to make things a bit clearer. So remember, the outer function is a parent function, while the function inside the parent function is its child function, and it has access to the scope of the parent function. So here's an example actually. Here's the demo code. In the blue box outside here, as you can see, we have the global scope. Remember, the global scope can be accessed anywhere, inside a function, outside, it's all accessible. Um, in the global scope, we have access to the a variable here. It's just a simple string hello. Um, the a variable is not inside a function, which means that it is set as a property on the global variable object. As we already know, all the properties of the global variable object are accessible everywhere in our code. So in our example, in the global scope, we have access to the a variable here, as you can see. Um, In the orange box, however, right here, um, we have access to the b variable, which contains hi, and as well the second function. And here's a good place to see what lexical scoping means. Thanks to lexical scoping, here the first function um, has access to all the variables that are declared in the outer scope. So the outer scope um, for the first function is the global scope. So here, the blue box. Notice how the blue box contains the orange and the green one. The orange one has access to whatever is inside the orange box as well as the things that are outside, so in the global scope. So as such, it has access to the a variable and the b variable. So finally, in the green box, we have the scope of the second function here. Um, in there, we have a log statement, notice console log here, which attempts to print out the values of the a, b, and c variables. And notice here that only the c variable is declared inside of the second function. So only the c variable is inside the local scope of the second function. However, due to lexical scoping, this function now has access to the scope of the function in which it sits lexically. And that's the first function here. So what that means is that whatever variables are declared here in the first function are accessible in the second function as well. And that's why um, we have access to the b variable, which is in the scope of the first function. That's how it knows the values of the a and b variables. Remember that um, This scope here, uh, the scope of the first function, contains also the outer scope, which is the global scope. So when we decide to run the second function, the JavaScript engine starts looking for the variable b and does not find it in the local scope of the second function. Then it looks in the scope of the parent function, which in this case is the first function, and finds the b variable there. The same happens for the c variable, but this time it's in the local scope here. It's readily accessible. Um, this traversing through the scopes is called the scope chain. And here we find the definition of a scope chain. What we need to know that is that in each execution context, what an execution context means is the environment that is created when we execute a piece of code, like for example a function. So in each context, an object that contains all the scopes is created. This object is in fact the scope chain, which looks in all contexts to find the variable we're looking for. So the scope chain is just a plain JavaScript object that contains all the scopes that we're trying to access. So let's go back. Um, it's very important to remember that this process does not occur backwards. So notice how we have here a red arrow that's pointing upwards. So from the second to the first, back to the global scope. It goes from the innermost function, so the second one here, which is nested the furthest. So this is the first layer of nesting, this is the second one, and this is finally the third one. This is the most tucked away in the code. Um, so the scope chain goes from the second function to the first and back to the global scope. It does not go backwards, so it doesn't go from the global scope to the first to the second function. This is why the global scope will never have access to the b and c variables, so we can't access the b and c variables from outside here. Um, unless we specify a return statement in the functions. So if we have here return b, we can access the b variable from the global scope. So locally scoped variables are not visible to the scope of the parent function. So after knowing all this, let's actually see the result of this in the code editor. So here we have the code editor. I've changed the text a bit. So here's JavaScript is awesome. And we have the console log statement, which logs the A, the B, and the C variables. So this is the sample code I've written. And let's see what the result of that will be. So let's flip over here. Here we have, as you can see, the code in the sources panel of the DevTools. And if we flip to the console, we can see that we have the result of all three of the variables working correctly. So the first variable, remember, contains JavaScript. The second one contains is, and finally the last one contains awesome. So we have JavaScript is awesome. So no errors here. The second function, thanks to the scope chain, finds all the variables it needs to print out the messages. Okay, so let's get back to the presentation now. Okay, so we've already seen that the concepts of the scope chain, the execution context, and scope are interrelated. So let's have another example just to get grips with it. with this example, I want you to understand that the execution stack is different from the scope chain. So um, here, the first function is called, which in turn calls the second function. As you can see, here the first function is called, and in the definition of the first function, the second function is called, which is here, um, which in turn calls the third function, which is way out here. For each function, a new execution context is put on top of the execution stack. And as you know, and as is indicated by this red arrow here, the function that is on the bottom of the execution stack will run first. So because we first called this function here, its execution context is put right here in the first place. After that comes the second function, and after that the third one. And notice how the order in which they are put here coincides with the order in which they are called. So first we have this call, then we have the second, and finally we have the third, not the order in which they are written. So for the scope chain, things are a bit different, as you can see here. All scopes have access to the A variable. Here, the global scope has access, the first function, the second one, and the third one as well. Only the third function has access to the D variable, as you can see here, D. No other function has, or even the global scope has access to D variable. Both the first and the second function have access to the B variable here, I, because, as you already know, lexical scoping allows that. The C variable is only in the scope of the second function, so in its local scope. It's not visible to the first one because remember, scope chain works backwards. From the most nested to the outermost global scope, not from the global scope to the most nested. So now let's remember that the execution stack is the order in which functions are called or run in our code, whereas the scope chain is the order in which functions are written in our code, lexically. So the order in which functions are run does not dictate the scopes of the functions. It is the scope chain that does that. As you know, the scope chain object. Since the third function is not inside of the scope of the first or second functions, it does not have access to the B and C variables. So hopefully that's a bit clearer on the scope chain. Here I have another representation kind of what's going on in the code. So notice how the global scope kind of encompasses all the other functions. Now, the same happens with the first here and the second function. So the third function, however, as you can see, has no access to either the first or the second function's scopes and vice versa. So the first and the second function don't have anything in common with the third function. So hopefully that's a bit clearer on what scopes are and the scope chain. So it's execution contexts that store the scope chain of each function inside the variable object, but they do not have an effect on the scope chain itself. So finally, knowing this, let's find out what actually will happen when we run the code that we had previously. So that's the previous example. Let's see this one. There it is. So the first function is called right here, which calls the second function, and the second function calls the third function here. So let's flip over to the Google Chrome browser. There's the second um, exercise or demonstration. Here, as you can see, the same code and what will be the result of that. So here we have an unconst reference error. So according to the code, C is not defined, but we've actually defined it. So why is it not printing? Um, I'm sure you know um, here C is not in the scope of the function that's being called. So the third function is completely separate, like we just saw from the second function where the C variable is declared. So it's invisible to the third function. So if we want to correct this code here, let's try removing this log and let's log the A and D variables. So A is in the global scope, which you have to remember is accessible to all scopes, including the local ones. So it's visible everywhere. And D is in the local scope. So in theory, now we should see the result printed to the console. So we should see JavaScript is phenomenal, which it's not always the case, but let's just assume it is for now. We have to refresh